Folks, I had a picture of this up on the board yesterday. Were you able to visualize that it looks like one of those coins that things go around? Yeah, right. You did a field trip to McDonald's. And I'm correct, everybody was here, and so you saw that yesterday. So if you're picturing it right, it's hollow in the middle, and it's solid here. So I want to try and picture a couple of radiuses. I think I'm going to have one radius come out here. Now, I don't really memorize these things. So yesterday, did I call that radius 1 or radius 2? Okay, let's call it radius 2. So that's the big radius. And then I've got another radius that also sticks out there. Which would be right on top of it, but you can't draw it if it's right on top of it, so that's radius 1. So radius 1 is the one that's tiny that's on the inside there. So I've kind of followed my steps. I made a graph. Step 2, I've made a picture. Step 3, I'm starting to see my circles. Now to actually see the circles, I ought to make that graph tilt out towards you, which on this graph I can't make it do that. If I go back to SketchUp, sometimes I can make it do it if I'm clever enough. Can you picture the circles if I tilt it at you? You can also build it out of clay, and we can cut it, and you can start to see the circles. So this guy looks more like a washer because he's hollow in the middle. So it's one circle with another subtract. So I think what I've got is a big circle subtracting little circle. We're going around the y-axis, so that tells me that I want a dy in there. I want an integral. This is a series of circles that are getting sliced starting here, going up to here. So the bottom is where y equals 0. Top is where y equals 2. So that means we're adding up a series of circles from 0 to 2. So the next thing to do is try and look at where these x's are touching, where the r's are touching. Will you notice that that r is in the same direction as x? So I would probably call this whichever x is lining up with radius 2, and that radius is squared. And then whichever radius lines up with R1 is squared. I need to get this in terms of y, which means that I need to figure out another thing to have here instead of the x's. And so pretty much you end up having to look back at the drawing. If I come back to my drawing, it looks to me like this radius stays the same the whole way. That comes out and touches the place where x is equal to 4. So I can just replace that with a 4. This other x is going to be just a little bit harder to see. Whoops, I put my 4 in the wrong place. 4 goes there. If I look at that other radius, it comes out and touches from here to that first line that we're touching, which means that we are touching the place where y equals the square root of x. So if y equals the square root of x, I think I could say that y squared equals x. So when I come down and replace this x, that x is replaced with y squared. Do I still have a squared term on the outside? I still do. So now he's set up enough that we can begin to solve it. So that's going to be 16. That's going to be y to the 4th power. For most of us, when you look at that one, it's easier to go ahead and distribute everything through. So I distributed the integrals and I distributed the dy's. Am I okay with that? And then when I look at that, it's easier to bring everything that's a constant number to the front. So there's no y here. This is like y to the 0. If you integrate y to the 0th, you'll end up with y to the 1st divided by 1. 16 pi. If we integrate y to the fourth, we're going to get y to the fifth. My negative sign separates them. I should include the constant. I should so that I'm going from 0 to 2. So put the numbers in. Almost everything goes away. So all those zeros drop out, and my constants drop out. So 2 times 16, 32 pies. 2 to the fifth is also need to get common denominators. Put a 5 here, 5 here. Here I have 5 32 pies. Here I have 1 32 pie. So that will simplify down to 4 times 32 times pi all over 5. 4 times 2 is 8. 4 times 3 is 12. Multiply by pi. Divided by 5. Give me a nice sentence.